Hey everyone, hi from Arizona. All right, so can you basically introduce my first slide? So I even put it up while I was introducing me. My lab is the Cognitive Neuroscience of Language Lab. And as you mentioned, we have 3 lines of research. They are kind of interrelated, but essentially metaphor, idioms, irony is one. And then we also study emotion and language, and you're going to hear a lot about emotion and language here. And then we also have some work on linguistic relativity. In today's talk, I'm going to report 4 studies that support my view of lexicosemantic representation. So we're going to talk a little bit about the overall big issue, and then I will present evidence that support dynamic representation of word semantics, and then we can have discussion and questions. So how do we represent word/lexical semantics? So I'm using these 2 terms interchangeably. So word synonymous, basically to me, word lexical here are synonymous to each other. So there's this static view where it says that the lexical representation is different from a conceptual representation. So in this diagram by Evans, there's this conceptual system here. Are you able to see my cursor?
Yeah.
I can't hear you. Yes?
Yes, we can see it.
Okay, excellent. So you just follow my cursor instead. So there's the conceptual system, and then there's the linguistic system, and they are kind of different and separated in some ways. So you have a thought, and then you want to put a verbal label on that thought, on that concept. Then you have to use your linguistic system to create a symbol. And then there you go, that's the lexical concept. There is some access point between the 2, but the 2 can be different. So that's a linguistic system. Within this, how do we represent lexical concept linguistically then? There are many, many theories. So to name a few, you can think about mental lexicon. So we list them as a list of senses. That's basically, if you have ever used WordNet, you know, the word run has 70 senses, and they were all listed. So one theory says our mental representation or the lexical linguistic representation is similar to that. Another theory would say, well, you know, argument structures and qualia, these are important, and you start to see brackets. So James Kutsievsky's famous, you know, representation is more like this. This is a linguistic representation. But what's lexical about semantics? There comes this dynamic view that says that words are stimuli that operate directly on mental state. So in this case, we have a verb cut, and then you have this multi-dimensional view way of representing cut. And each time you use cut, it really depends on the context. In the early days, actually, Rumhar already suggested that words convey meanings, but words do not have meaning themselves. It's kind of a pointer pointing to kind of meaning. And also a computational linguist, Adam Kilgariff, famously in his article entitled "I Don't Believe in Word Senses," said that word senses are abstractions over clusters of corpus citation. So clustered according to context, basically. So my question then becomes, when does context influence meaning? Because, you know, eventually context does exert some influence on meaning representation, but when does this start? So according to the static view, there should be a stable, relatively stable mental lexicon. A word form would be retrieved, and the word form would retrieve an invariant lexical representation first, and then tailored to fit the context. So if you have a word form SNAKE, And then some sort of linguistic representation comes out first. And then the context is, we ask the participants, think about its emotional meaning as opposed to other types of meaning. Then you start thinking about the dangerous feature of snake. According to the dynamic view, then, word forms are simply cues to construct meaning. So meaning is constructed, not necessarily retrieved. The information that gets activated is always co-determined by the word and its context. So we skip a step. You don't need to have a linguistic representation first. You just directly have a hybrid, of context. The context, again, here is the processing goal, where participants need to be asked to think about its emotional meaning, and then we have kind of a joint representation here. So to test this overarching hypothesis, we developed many studies. So today I'll report 4. The first one looks at the effects of mood influence how we read. And here, so we view mood as a kind of context, right? Because processing goal, it's kind of a speaker context. So literature has told us that mood does influence processing in 2 ways. The first kind is content. So mood facilitates mood congruent content. So if you're grumpy, then you're more likely to spot grumpy words. There are grumpy words. So that's when the content of the stimuli is emotionally loaded. Another way that mood can affect processing is in terms of processing style. So this says that mood doesn't influence the content per se, but it influences how you're processing the words. So for instance, almost 20 years ago already, Kara Federmeyer already reported that positive mood facilitates spreading activation of meaning in language. So when you're feeling good, then it's the spreading activation. Has nothing to do with representation. It's the processing that gets sped up. So and also Dorothée Kawila in 2013 reported that negative mood draws attention to details. So these have been reported. There aren't a lot of mood and language studies, but there are about, I would say 30, so 40. So here we looked at discourse processing. We hypothesized that mood affects discourse processing. During discourse processing, readers have to strike a balance between their default word knowledge and the local text, so the thing that they're reading, in order to build a coherent discourse model as the discourse unfolds. So I know this hypothesis is very general, but because there were not a whole lot of ERP studies on mood, so we kept it general as we started that experiment. But we do think that it's possible we're gonna see differential effects from positive mood and negative mood. So after we had the hypothesis, we started building stimuli. So all the students here probably are very familiar with this process. We built stimuli. We constructed a lot of stimuli for ERP studies. Oh, I'm sorry, I don't have a ERP 101 slide because I assume this is Brennan language talk. So I assume, so sorry. So, okay, so the stimuli we constructed look like this. So we want to have a something that has inconsistency between real world knowledge and what's actually presented in the text. So in this case, in the real world knowledge here, so it's the top left corner. Usually we think that with the lights on, you can see more at night. So that's our default world knowledge. And in this case, in this cell, the context is congruent with this region. So more and more lampposts are placed in the Netherlands. This way, it is easier to see the road. This is nice for drivers, okay? But there's also a more of an infrequent context, which is stargazing. So here, oh, I'm sorry, it's actually here. More and more lampposts are placed in the Netherlands. This way, it is harder to see the night sky. This is sad for astronomers. With the lights on, you can see more at night. So like this, we have kind of a 2x2 combinations, and we created a 2x2 design basically. So what we did is that we ran a within subject design. So participants came in twice, once for a happy session and a second time for a sad session. And what they have to do is to, first, their mood was manipulated. They watched film clips, like, you know, to be put in a happy mood and a sad mood. So for happy mood, we use the situation comedy Friends, and for sad mood, we use the movie So His Choice. And we verified their mood was manipulated, and then we started their language tests. So because as I have shown you in the previous slide, that was a lot of text. So we use auditory representation for the context, for the discourse context, and then when it was the target sentence, participants started reading target contexts on the screen. So, right, so these are the stimuli again, and I put the picture here to say, basically to indicate that participants' EEG was recorded throughout. So first result is we wanted to check if the mood manipulation was successful. In general, for the negative mood, which is represented for the darker line here, did go down from time 0, time 1, time 2, time 3, time 4 to time 5. So we actually checked their mood 5 times, because as many of the people in the audience know that ERP session, EEG session is long. So we just wanted to check if they're still sad or happy in that case. However, in this light line here, their positive mood was not really successful. Let's just say that it's hard to make people happy. But it is, you know, the sad mood was significant, and there is a difference between sessions. So if I want to just point out that there is a difference between sessions, and that's important for our to go on ahead to look at the ERP results. And here's are the ERPs. So if you would just bear with me. So first we have the happy sessions on the left, and then we have the sad sessions on the right. I want you to focus on this later time window. So 0 represents the onset of the target words, such as more and or less, okay? And then so counting from 0 onwards, there's a difference in the late positive component time windows between the happy sessions and the sad sessions. And remember, these are the same participant, because it's a within subject design, and they were reading the same material. So the only difference was their mood. So there's a difference between these two here. And what exactly is the difference? So if you would notice that all the colorful lines were together, and whereas the black line, which is the with the lights on, you can see more in a driving context. So that's all coherent. So that is basically you can view that as our baseline. Actually, I think I'm sorry, I made a huge mistake. This is the sad session, and this is the happy session. Sorry, this is quite a big mistake. So just reverse this. Basically, when in the sad sessions, if there's anything with a little bit of a glitch, a minor mistake or a big mistake, the sad session participants notice that. So that's the general finding. So this is basically a summary of what you just saw. That readers in happy and sad mood states can process some outright semantic violation fine, which was what we call in the semantic N400 time window. So not the late effects I just showed, but here, it's basically these two are the same between sessions. You might ask, oh, this is a little bigger for the happy session. Okay, this is too confusing. I'm gonna have to just edit it right here so that we don't get confused. Yeah, you might say, well, you know, look, this blue line here, the stargazing context, and with the lights on, you can see that it listed a bigger N400. But unfortunately, this didn't reach significance. It's like P equals 0.08. So there's no, I can't really tell you that's different there. So in any case, within the N400 time window, that the happy and the sad mood didn't influence that window according to our data. And that time window is, we say that we associate that time window with retrieval. So we say retrieval is not influenced by mood. But we did see differences in the P600 time window, and we call that we think it's a semantic P600 because there was no grammatical mistakes here, grammatical errors in these stimuli. So we suggest that readers in a sad mood state analyze and reanalyze any incongruency, no matter how small those incongruencies are. And this is basically, we were interpreting this P600 based on some accounts that said that it reflects people's reanalysis. And this part, this reanalysis is influenced by mood. Okay, so that was the first study that shows you that there's, you know, there's kind of a dynamic word representations that can be dependent on the reader's mood states. And the next study is emojis. So it's conducted by my former student, Valeria Pfeiffer. She's now a postdoc in this lab called Naturalistic Observation and Social Interaction Lab, also at the University of Arizona. So our question was, how do facial emojis influence the representation and processing of words? So there are several hypotheses in the field, and I have to tell you that these hypotheses were not really postulated by these researchers, but was kind of, we did a summary paper, we reviewed their data and positions, and we kind of articulated it for them. So the first position says that emojis, you know, make their accompanying text appear more positive. Doesn't matter what text you go with it, as long as you put emoji there, you know, then suddenly your text becomes positive. And the second one says, well, no, only positive emojis give rise to positive feelings of the word. So if you put a frowning face, then your text is going to be will be made more negative. The third hypothesis or third theory says, no, emoji doesn't contribute to content. It basically facilitates or confirms pre-existing text emotion. So if your text emotion is positive, then, you know, put an emoji there, it will just stay positive. It cannot convert it into something negative. The fourth theory says emojis draw focus to specific words. So because it's like emphasizing on the word that's next to and leading to in-depth processing of the word. Okay, not the emoji, but of the word. Just, I want to be clear that we're not looking at emojis, we're looking at the words, how emojis influence words. And the fifth last and final hypothesis says that, well, emojis don't do anything to text or words, or basically it's a pragmatic function. They help maintain a connection between the sender and the receiver during texting. So that's the social function. So what we did here was that we created three conditions. The three conditions were, the first one was the control, comma. So we just put a comma there. And then we have the happy emojis. These exact happy emojis, we got these emojis from there was like a lot of pretest and the selection of emojis. I can tell you more if you're interested later. And then we did pretest to make sure that they are positive and happy. So on the Likert scale 0 to 6, they were rated 5.1 as being more positive emojis. So it's positive negative scale. And these are the upset emojis that we use. So we use these emojis and we combine them with 102 text messages. And so that outputs 300, 400 kind of items. And so during the experiment, participants saw something like this. So fixation cross, hey, emoji, are you ready? Okay, and then participants had to answer a question. The question was, what is the mood of the sender? Okay, so we, based on this question, we checked their responses and saw that the manipulation was verified. And this is the results, the ERP results. So I put these words here so that you know. So this here is the first word. So there is on the left-hand side, these two figures are the first word. FZ represents the electrode on the frontal part of the brain, and PZ displays basically is the electrodes on the parietal side of the brain. Both of these were used in language studies very often. So out of 32 electrodes, we selected 2 electrodes, one in the front, one in the back. So the first word right after emoji was this word. And this, again, 0 is the onset of that first word. And we saw that essentially there's no difference between the, no difference between the happy and upset emojis. There is a clear difference between the control condition of coma and the emojis condition. So if participant just saw the coma here, then that's the black line. So that's fine. So we move on to see the second word. Okay. So the first word here, it says please, but sometimes in many of our stimuli, there could also be like, hey, how are you? So then that how is not exactly a content word. So that's another motivation to go on and look at the second word. So these two figures on the right side of the screen are the second word. So these second words, the first word, the top graph, likewise is the frontal part of the brain, the scalp, and the bottom graph here is the back of the scalp. And we do see a difference here, not in this window, but we saw a difference here. This didn't turn out significant, this early effects, but we did see late effects. So such that the upset emojis here elicited had more of a sustained, you can call that a negative, or alternatively, the second word after the happy emoji gave rise to a late positivity ERP signal here. Okay, and it's more posteriorly distributed, so not frontal. This is smaller in the frontal side and bigger difference here in the posterior side. So what do we make of that? So we return to those several hypotheses in the field. So we cross out the first one because the first one says emojis, regardless of whether it's a upset or happy, they would just make the text appear more positive. But no, that's not the case. We did find differences here, which is actually supporting the second hypothesis. They do affect the following words, or the second word following the emojis in valence specific ways. And likewise, the third hypothesis is rejected because emojis added new information to the words, did not just confirm pre-existing text meaning or emotion. And this new information could be, and we didn't test this, so we'll have to make a manipulation that's focused and unfocused to test this specific hypothesis. But indeed, this new information could be used to draw focus on specific words, like the second word. Okay, so like content words, not function words, leading to deeper processing of the word. If you remember also in the first study, this part would be the reanalysis part. Well, researchers have shown that the P600 reflects reanalysis. So it could be that adding emojis, then people try to think about the content word meaning deeper, as reflected by this part of the effect. Okay. And the fifth one was actually tested in our other paper, and emojis help maintain a connection between the sender and the receiver during texting. In that paper, we found that we found that it was just a positive emojis. So adding a positive emoji, adding happy emojis help maintain this connection. But happy emojis don't do other content modification kind of things. Negative emojis do. So now we come to the third study, which is, again, we're going to look at the word representation, how it is influenced by swear words. Okay, this is conducted by Dr. Stanley Donahoe. Stanley was my former student, and he is now a scientific consultant at the Brain Vision company that actually whom we buy the electrodes from. So alternative way outside of academia, you know, so now it's working on electrodes. Stanley was from the linguistics department, actually. So his interest was on expressives versus descriptives. So expressives are things like swear words, you know, for instance, and descriptives, you can think about adjectives like green or red or old or new. Okay, so semantically express speaker attitude, whereas descriptives describe and modify content meaning. And structurally, the two are also different. Expressives can be local or non-local, according to Gutzman. For instance, I lost my damn watch, and now I have to get a new one. This expressive can modify the noun adjacent to it, or it can modify something not locally adjacent to it, like so the frustration of the speaker. So that's an attitude. Whereas if you look at descriptives, green is only used to modify its adjacent noun. It doesn't modify the person losing the green watch, doesn't modify the agent, cannot. So in a previous study, Stanley and I looked at just single words, expressives versus descriptives. And we found some interesting effects here. So here, again, this is data, but I want you to focus on the swear words, which is the red line here. And then another word I would like you to focus is negative words. So the blue words. We matched the valence of swear words and negative words, actually. So they're equally negative. But still, even when their valence rating was equally negative, the swear words elicited an extra sustained late positivity here. So you compare the blue line and the red line, you see this effects here. So yeah, so there is a neural difference here between the expressives and descriptives. And in that paper, we just argue that that's reflecting the socialness of these swear words. So, but we want to not look at single words. We want to look at sentences, and we want to understand how expressives affect the following words. So we designed this second experiment where we basically had 3 conditions. And here's example 1. And I'll read this, the black dog peed on everything. So the black dog, the black here, that's the descriptive, that adjective. And then in the expressive condition, we have the damn dog peed on everything, right? So that's the expressive, and then followed by dog. And we threw in pseudo word conditions. The flurg dog peed on everything. And this is a control. We just wanted to make sure that the experiment worked, because we don't want to interpret things too much, because this is, again, very new research. So we want to make sure that the experiment actually worked. There are example 2 and example 3. But I think it's not so appropriate to pronounce the word here in a public speaking situation, so I'll just skip this. Yeah, so the participants, here's the procedure. So the participants saw the damn dog peed. They only saw one of the 3. So this is just for this presentation. It's not that participants saw all 3 at the same time. It's one of the 3 here. So ERP was time locked to dog, right? We're not interested in adjectives, these expressives. We already done that in the first paper. So we're interested in the nouns that follow swear words. And the task was passive reading, and participants completed yes/no comprehension questions for 20% of the trials. And those were used to verify participation. So they were pretty good participating. Actually, undergrads really like this experiment. I suppose it's because it's swear words. So we're looking at ERPs at the nouns. Again, not the swears, at the nouns. So I underlined here the black dog, that's the black line. The damn dog, red line, and the flag dog, the pseudo words. We actually don't quite need to look at the pseudo words because they have a different function there, but just to put it here. So compare the red line and black line. So here we actually see something really early, like P200. There's already a huge effect here and here. So if you think that, yeah, wait, okay. So, and then we also saw 400 and 400 here, and then there's the LPC over here. So let me just show, well, actually, so we argue that there's the frontal P200 at the nouns. They probably reflect social emotional features of the swear words. So not the swear words. These are nouns, not swear words. Okay. So at this point, you see, compare the red line with the black line, and we suggest that the expressives did modify the meaning of the nouns in a very early way. And it's not posterior. And so we understand, we're aware that some researchers associate P200 with combinatorial processing, but we're using the frontalness of this. So this is the frontal electrodes, and this is the posterior group with the electrodes in the back. So that's what we're arguing. And in the M400 time window, that's also a very frontal effect, different from classical M400. So in this case, we associate this with mental imagery, saying that in the case of black dog, okay, so let's go back to this here, it's actually the black dog, the dog after black that elicited the largest M400. So we suggest this, there's more combinatorial processing going on there. They're imagining a dog that is black, but if you're saying damn dog, they might not be able to imagine visually, mentally imagining the dog being damned. Okay. And the next effect is at the LPC, and again, we suggest that this is associated with reanalysis and emergence of a new combined concept such as black dog. But it is not in the, sorry, let me go back. It is not in the, it is posterior, and we also don't see this in the nouns after swear words. So here we argue that in this expressives condition, readers simply were in a wait and see state. So they, they were alarmed by it. So we saw that P200, the early signals, but they were not in a hurry to integrate it with the adjacent nouns, or because they are kind of waiting to see what else is in the sentence before they want to select a non-local word to be integrated with the swears. Okay, so now we have study 4. how am I doing time-wise? Is this okay? We go on to study 4, or do we just stop here? Can I get some feedback from this?
Yes, we still have like 10 more minutes.
10 minutes, okay. So I will be quick. So for study 4, we're looking now at emotional context on words. So the question here is in the title of the slide. This is the research question. How do emotional sentences influence the neural representation of a word? Well, many people have done that. So you can see these citations here. But most of these people adopted a violation paradigm. So they combine emotionally incongruent words with, they combine words and sentences in an emotionally incongruent way in order to elicit ERPs. Here's an example. Julie explored the enchanting garden. The strong smell of decay surrounded her. So enchanting garden, those are positive, but this decay, this strong smell of decay, that's negative. So that's what we mean by emotionally incongruent. And these studies reported N400 and LPC. And they argued that this N400 was the detection of an incongruence features of the word, which fits the general explanation of, general observation of N400s in the broader literature. And we also have the LPC, which was argued to be the update of the incongruence feature of the word. So updating reanalysis. So the present study, we examined something that is not violation, not in a violation paradigm. We want to go a little more natural. So we examine things like the pianist. Okay, so our target word is the pianist. The pianist had a new performance. Her skill was rusty. Okay, that's bad. So then we measure the ERP again at the second occurrence of this word pianist. Then we compare the first occurrence and the second occurrence of the word to see, if there is any difference. So due to the context of rusty. So our hypothesis is that this context emotionality will modulate word representation, even it's the very same words. We're not comparing anomalous words with regular words. We're comparing the pianist, this target word, to itself, first mention and second mention. Sorry, this is not supposed to be there. So here is what we developed. I'll use a 2x2 design. So you already saw the pianist and rusty. And then, so in a positive context, we say the pianist had a new performance. Her skills were remarkable. The pianist practiced every day. So we basically compare ERPs of the second mention and the ERPs of the first mention. In the negative topic in red, so the dentist is rated. So in our pretest, it turned out to be negative. The dentist often worked with children. They found him trustworthy. Okay, trustworthy is a positive context. So then we assume that the second mention of dentist will be changed to something more positive. And the last cell here, the dentist often worked with children. They found him formidable. So the dentist care about them. But then at the second mention, we assume that this feature, it will become a negative word. So here's the procedure. Participants read all of these. That's a little hard on their eyes, but we presented one word at a time. Those were long context. So we just time locked ERPs to here, the first mention of pianist, and then you see this important context here, in this case, remarkable, and this time locked ERP here, the second mention of pianist. They do have a task in the very end. So they would ask if, the target, basically the pianist in this scenario feels, is it negative or positive? So we wanted it's a valence judgment task. So you can ask me a question, what if you use semantic judgment task as opposed to valence judgment task later? But that will be later. So here are the results, and this is a little busy, so please bear with me. So let's start with the top left corner. So here you can see the 0 is the onset of the pianist. And here actually we subtracted, here is the, I'm sorry, I should have made this more clear. We subtracted the first occurrence of pianist from the second occurrence of the pianist. So this is already subtracted basically. So the red line represents positive words, positive target words in positive context. And let's look at this blue line here because there is something here. The blue solid line represent the negative target words in negative context. And there's a P2 here, and such that it's only, it is significant here. And then we also observed a late positivity component. And in this case, in this case, it is the negative context. So it's the negative context that gave rise to this late positive component. So once more, let's look at the summary of the findings at the bottom right of the screen. So for P2, we have reduced P200s. So these bluish heads is kind of a reduced activities, negative. So we have reduced P2s for positive targets. So those dentists, think about those words like not dentist, pianist is reduced P2 for reduced from the second, from the first occurrence to the second occurrence. And then for the LPC, we have enhanced LPC for context. So it doesn't matter what kind of words you have. If the context is negative, then you have an enhanced late positive component. So summarizing what I just said, we suggest that this reduced P2 is basically reduced automatic attention to the second occurrence of the positive target words. And the LPC reflects basically the results of LPC reflects the increased sustained attention to the second occurrence of the target word after negative context, so only in negative context. So it seems like our participants were very focused on context. So regardless of dentist or pianist, as long as your adjective is bad, like formidable, then they show increased LPC. And if the target word is positive, like just pianist, and then regardless of context, there is a reduced automatic attention. So they didn't pay attention to the positive words no more. So such findings supports a negativity bias, which is kind of makes sense because our participants, younger adults usually have this negativity bias, focusing on information that's more negative. As we age, this negativity bias flips into a positivity bias. But our participants had an average age of 18.8. They are non-depressive. We've done all kinds of neuropsych tests to make sure that their cognitive functions was okay and non-depressive, etc. So take-home message is that negative context changes the semantic representations of a word. So here we are at the general discussion. I just have 2 more slides. So I just wanted to say, coming back to the overall framing that I mentioned at the beginning, when does context shape word meaning? So it appears that across our 4 studies, we've seen some, so LPC is around, just think about it as 600 milliseconds for now. So effects of mood and effects of facial emojis, those seem to be less linguistic. So here, less linguistic. And when the context is less linguistic, it seems like the context changes word representations at a later stage. When I say later, it means about half a second after the onset of the word in context. Now, when context is more linguistic, such as swear words, such as those adjectives, right? In the last study I reported, this context was basically whether the dentist was, formidable or trustworthy. So those adjectives, those are pretty linguistic. So in this case, context can hold sway on the word representation earlier. And if you remember in the swear study, the effect started at 150 milliseconds. That's pretty short. And in the study 4, the context effect started at about 180 milliseconds. Okay, so I put a tentative here because we continue to explore, do studies here. So here's tentative conclusion that our findings so far, support a dynamic view of word meaning. No word sense must be invariantly encoded or retrieved in a word, and rather words provide clues to meaning. That was the talk. Thank you.